Okay, so now we are going into the code build subject. And so AWS code build is right there in the middle after code commit, and it's going to be used for building and testing our application. The idea is that it can do both because they're kind of the same thing. When you build something or you test something, you just provide commands to a server and the server does something as part of the command. It could be building or it could be testing. So let's do a deep dive into code build. So it is a fully managed build service. What does that mean? That means that like as an alternative to other tools such as Jenkins, it's going to be able to continuously scale. And so as a user, you don't have any servers to manage or provision. There is no build queue. If you have a tool such as Jenkins, for example, which is an open source build tool, this time for Jenkins, you have to provision it onto your EC2 machines and make it run and provision Jenkins agents. And then when you have builds, if your agents are busy, they go into a build queue. Not with code build. With code build, it's fully managed. It scales a lot. So basically, you don't manage any servers, you don't install anything or provision anything. And so as you have build requests coming in, code build just goes ahead and builds it for you. You pay for the usage of code build as well, which is really, really nice. If you had a Jenkins box, for example, just sitting around in your infrastructure and just doing one build a day, then you would be overpaying for sure, right? It would not be busy at all the time. Whereas for code build, if you do one build a day, that is fine because you are only going to pay for the usage of your development server or your build server. So if it takes you 1 minute a day to complete builds, then this is what you're going to pay for. Code build under the hood leverages Docker. And so Docker is, I know, an advanced topic as a developer. I hope you know about it. If not, I would recommend you go online just to read a little bit about Docker. But Docker basically allows for a reproducible builds to happen onto various kind of operating system with different configurations. It is also possible to extend the capability of code build again using Docker. So instead of using the Docker images provided by Amazon for code build, we could create our own base Docker images for code build. And so this will enable us to have more customization over the build. Now code build is secure. So it has integration with KMS when you want to encrypt build artifacts. So build artifacts are build outputs basically. It has integration with IAM for build permissions. So whenever code build interacts with other AWS components, it will use IAM. You can run your code build within your own VPC if you wanted network security, and you could use AWS CloudTrail for API calls logging. So overall, it is fully integrated with AWS security. Now, if we look at an overview of what code build does actually, well, it can source code from various places: GitHub, Code Commit, Code Pipeline, S3, Bitbucket, etc., etc. And the build instructions, that's super important for the exam, can be defined in code. And this file is called the buildspec.yaml file. Very important. Now the code build logs, basically, they are outputted to Amazon S3 and AWS CloudWatch logs. And so this is something you can configure, but basically when a code build finishes, the whole container that ran the build goes away, and the only thing you have left for you to troubleshoot with is going to be these logs in S3 or CloudWatch logs. You also have metrics to monitor code build statistics and make sure it doesn't time out or fail. And as such, you can use CloudWatch alarms to detect fail builds and also trigger notifications. So just remember, these are CloudWatch alarms. You can also use CloudWatch events and AWS Lambda as a glue for everything and trigger SNS notification. Finally, you're able to reproduce code build locally to troubleshoot in case of errors. And there are two ways to define a code build, which I find quite confusing. And you can either define a code build within your code pipeline. That's what we're going to do in the hands-on. Or you can define a code build in code build itself. And I find this quite confusing, to be honest, especially because these two ways can interact sometimes and not really play nice with one another. So bottom line is we'll use code pipeline for this hands-on. Now, what does code build allow you to build? And by default, you know what Amazon provides you. It is Java, Ruby, Python, Go, Node.js, Android, .NET Core, and PHP. So all these are provided for you, and I probably might have missed another, and I'm pretty sure Amazon works hard to add environments as we speak. But if you wanted to say, oh, I don't have my Haskell environment, can I build it? Yes, you can, because you can use Docker. You can extend any environment you like. It's just up to you to create these Docker images that are going to be supporting your build. And that's what I really like about code build. It is fully extensible, and the base of it is Docker images. So how does code build work? Because a diagram is always helpful to cement your learning. Well, we have the source code, and for us, that will be code commit. And so as I said, you need to have a build spec.yaml file, and that file is going to be at the root of your code, okay? We also need a build Docker image, so we can either use an Amazon managed Docker image, or we could build our own. That's why I say custom. And so you don't need to know Docker to use code build, but it's good to know that code build leverages Docker under the hood. Now there's going to be a code build container that is going to start as soon as your code build is triggered. And so the the container of it, and container is a Docker specific term, is basically using the Docker image we set from before as the source image for the run. And then the run instructions themselves, as far as like what will the container do to build our code, is coming straight from that build spec.yaml file. That's why it's so important. Now there's an optional AWS S3 cache bucket, and basically that means that as you go and do multiple builds, you're able to cache, for example, dependencies or artifacts or that kind of stuff. And so you can pull in this cache when your build starts, and in order to basically increase the performance. Now your code build finishes, hopefully it passes, and if it passes, it will send the output to an Amazon S3 bucket, and that will be your artifacts bucket. So anything you create out of your build, could be binaries, could be zip file, could be whatever you want, you put there into an AWS S3 bucket. And then as far as the logs go, the logs at the end will be saved into Amazon CloudWatch or Amazon S3, so you can look at them across all your builds. And then finally, because it's a cache and you have to write to it, at the end of your code build, if it succeeded, the cache file within your code build will be put back into S3, again for having that feedback loop. So this is a little bit of a full diagram, but it really shows all the building blocks and moving components of code build. So have a good look and try to recognize what's happening. But the most important two things is going to be the build spec.yaml and the fact that it runs on Docker. Okay, so let's talk about that build spec.yaml file. It's a file, and we'll be creating it in the hands-on, and it must be at the root of your code, okay? Nowhere else. It must be named build spec.yaml, and it must be at the root of your code, so not within a subdirectory. In there, we can do a lot of things. The first one is define environment variables. So we can have plain text variables so that they're like out in the open in your code. But if you wanted to have secrets, we can use something called the SSM parameter store. We'll see this in the future lecture. But basically, you don't ever store secrets in your code. That is just common sense. And so code build is smart enough to pull in secrets from something called the parameter store. Now the phases is basically the commands to run as you go along. And so there are 4 phases. There is the install phase, and it's just, conceptually to install the dependencies you may need for your build. So this is where you run your command, for example, to install Maven or whatever you need. Then there's the pre-build. So these are the final commands to execute just before your build happens, and that's after the install. Then there's the build. So this is your actual build commands. So what is your code build going to run as a command to build your code? And then finally, if you need some finishing touches, there is the post build. For example, if you wanted to create a zip about everything. So what you remember out of this is that there is a bunch of customization you can do, and there's install, pre-build, build, post-build that execute in order. At the end, we get artifacts, as I said, and so artifacts is what we upload to Amazon S3, and these artifacts are encrypted with KMS, and so this is where we define those. And finally, just as before, remember there was a cache. You can define the cache here and define which files you should cache, usual dependencies for future build speed up. So that's a performance improvement. So this build spec.yaml may be very confusing. We'll just create a very simple one at the next lecture. You're not actually supposed to know how to build one. You just know it should exist and that you can actually define a lot of things in there. So just remember this. Now we can do, as I said, a local build on code build, and that's if you want to do a deeper troubleshooting beyond the logs, and you can run code build locally on your own desktop, and you need to install Docker for this. And for this, you also need to leverage something called the code build agent that is quite advanced, but if you're interested, just Google code build agent and you should land on that link. So that's it for the intro to code build. I will see you in the next lecture for the hands-on.